algorithm. Okay, is a elliptic curve cryptography algorithm. Basically it is used to generate a public key. Okay, basically it is used to generate a public key along with the private key. Okay, and as compared to the RSA key, it generates a public key which is very short. Okay, and that's why the data transmission is very fast. And second advantage of ECC is that when we generate the ACC key, so basically, so when we use the ECC key, basically along it generate the public key along with the private key, and basically the private key used for the data decryption and public key used for the data encryption. And then second is the patient registration with the hash and pseudo ID. Then after generating the public key, the next step is we register the patient. Then next mutually authenticate via the hash token. Okay, means what? Every time whenever we want to register the new patient, okay, for the purpose of detecting the problem related with the patient, for that time every time it generate a new hash token. Okay, that means every time it is necessary to apply the ECC algorithm to generate a new public key, to generate a new private key, and based on that public and private key, it every time it generate a new hash token. Okay, basically hash token means what? Is nothing but the identification of that patient. Okay, then number 5, dynamic session key for each communication. Okay, that means the whatever the key generated by the ECC algorithm is not a static, it's a dynamically. That means for each and every registration, whenever we register the new user or whenever we modify the data of the patient, so that's time every time we generate a new app or separate key. That's why it is known as a dynamic session key, and it achieves 98% secure packet transmission. Okay, that means there is a less chances of the internal modification of the data during the data transmission. Okay, now number 2 is two-level hybrid meta-heuristic secure federated cluster routing protocol. Yes, so basically what happened here, basically it is efficient, secure and energy-aware routing in healthcare network using the hybrid meta-heuristic. So basic objective is efficient and the security, that means we securely transfer the data. Okay, so here for the purpose of transmitting the data, basically yes. Okay, so whenever the sensor collect the data from the different sources, okay, so that time based on their similarity, first it organize the data into the different form of the cluster. So again, for each cluster there is a cluster head, that means the team leader, and cluster member, that means another workers. Okay, so whatever the result produced by each and every cluster, or those results are again combined into the singular result. For that purpose, whatever the result generated by each and every cluster, again we need to check which result is better. Okay, for that purpose we need to apply the optimization technique, and this optimization technique is applied by the MTBO optimization algorithm. Yes. These are the steps proposed by the authors for the purpose of secure monitoring, storing and transmitting the patient data. First is the prioritization, that means whatever the data capture, proceed, store or modify by the authenticate user, okay, or those data, that means we need to apply the high level priority. Okay, second is the state space. Basically it includes the different kind of the algorithm, that means BPHR, action space, define the priority level, that means here we need to provide the accessibility level, that means here we define the role of the user, and according to the role of the user we give the access to the users. Okay, then rewards, align priority with, then CF, weight, medical parameters. Okay, so now depends on the problem of the patients. Okay, there are different parameters, like if we consider the cancer treatment, then we consider the different parameter. Okay, then Next is train AI. So basically here we create a supervised learning model. Then STDL, combine the CNN and transformer. Then phases, 3 stages for the feature extraction. Yes, these are the 3 stages. First, whatever the data are collected by the sensor, data transmitted to the DGW, then DS, and finally data stored in a storage. These are the 3 stages. Then self-attainment, that means detect if there is any abnormality or any problem is occur after the data processing, then we need to identify those problems, and finally we calculate the accuracy generated by the algorithm. Number 4 is sequence storage with the cloud assistant redactable blockchain. So first, the patient data as blockchain transaction, that means whatever the data collected by the sensor, that means MIoT devices, all those data are transmitted into the blockchain, that means the block. Then block with the verified link transaction set, that means once we generate the block, okay, one can verify the block, that means whether the block or authenticated block or not. Then redactable blockchain allow the authorized edit, means whatever the data here we store in a block, if someone want to edit that block, okay, so redactable blockchain technology gives the permission to the user. Then redactable update transaction and hash function, whenever the user want to perform any kind of updation, modification or deletion operation, so for each and every time it is necessary to generate a separate or fresh or new public key, okay, and hash key, and smart contract control access permission and traceability via the reversible audit trail, okay. And again here we perform the audit operation, that means when we perform any updation or modification or deletion operation, okay, so all those operations are authenticated or not, okay, so we need to check all those things. Now, okay, so basically learning outcome from the paper, the first is it integrates both the edge computing and blockchain technology. Second is it improves the scalability, real time decision making, and it provides the data security because it uses the redactable blockchain technology, where one can easily modify the data but with the prior permission, okay. And second is redactable blockchain allows the secure modification while preserving the integrity, that means whenever we make any modification, any changes or any kind of operation, okay, but we can change the data on it, okay, but it doesn't allow us to change the structure of the block, okay, that means it always preserves the integrity. Learning outcome 2, innovative data processing technique, okay, so whatever the data collected by the different IoT sensor or devices, all those, so based on the similarity among the data collected by the IoT devices, it first form the cluster, okay, and every cluster predict their own result, and finally it combine the result, okay. So then next, hybridized meta heuristic secure routing enhance the network lifeline and efficiency. Multi-agent deep reinforcement learning algorithm, yes, for each and every problem related with the patient, the problem handled by the separate agent. That's why it is a multi-agent technique. Learning outcome 3, enhance the patient care and system performance by using the redactable blockchain technology. Yes, suppose initially if the patient come with the doctor, okay, and after all the tests, if the doctor store all the data related with the patient health problem in a cloud server, and after some days again if the same patient visit and meet with the doctor, and after the test if it is found that there is no problem, that means that's why we need to update the patient data, na? Okay. So that's why means we improve the performance of the system by the regular updation of the system data, okay, and regular updation of the system data is achieved by the redactable blockchain technology. Then hybrid transformer deep learning achieve the high accuracy in abnormality detection, and overall system reduce the delay, increase readability and support trust-based healthcare delivery. Then next, what is the key lesson? The first is it is a secure remote healthcare because it provides it ensures that the privacy and security. Second, WBS gateway, edge and cloud integrated security, that means it uses the 4-tier architecture. Number 3, authenticated accession key protect the sensitive medical data. Means whenever the user want to log in with the system, or whenever the user want to transmit, proceed or perform any kind of operation, so each and every time the ECC algorithm is applicable. Okay, and whenever it applies the ECC algorithm, that means every time it generates a new public and private key, and every time for each and every transaction there is a separate generation of the hash token. Okay, that's why it is a more secure process. Then next, key lesson 2, intelligent data processing. So basically multi-agent deep reinforcement learning. Okay, it uses the multi-agent deep learning reinforcement technique and hybrid transformer deep learning technique, and it boosts the accuracy of the diagnosis. And last, key lesson 3, redactable blockchain integrated with the cloud storage. Yes, whatever the data processed by the system, all those data finally stored in a cloud. Okay, but if someone want to modify the data, so after the modification again the changes are reflected in the same cloud. Okay, that's mean here the redactable blockchain technology integrated with the cloud storage. Okay, means what? Whenever we want to read, or suppose we want to read the data from the cloud storage, okay, then every time we get or we read only the updated data. Okay, then it allows the secure update while preserving the data integrity. That means we only perform the modification or deletion of operation using the redactable blockchain technology, but it doesn't allow the user to change the data integrity or to change the existing structure of the block. Then enable the trust-based healthcare recommendation. And finally, the implementation plan of the system. Step number 1, it is necessary to deploy the wireless body sensor on the patient to capture the vital sign. If patient have any problem, okay, so using the MIoT, medical IoT related devices, okay, first we capture the patient data. Then second, we need to establish the distributed gateway for data aggregation. Yes, distributed gateway. Using the distributed gateway, then we transmit the data for further processing. Then number 3, implement the authentication protocol with the session key to ensure the secure communication between two nodes. Okay, that means here we need to apply the ECC algorithm for the purpose of the data transmission. Then integrate the blockchain server for the trusted registration and authentication. Then train the healthcare staff on the secure data access and monitoring the procedure. This is the first implementation plan. Second, we need to apply the hybridized meta-heuristic secure federated cluster routing protocols, okay, for the efficient routing. Then deploy the multi-agent deep reinforcement learning to prioritize the emerging healthcare data. Then integrate hybrid transformer deep learning model for anomaly detection and continuously optimize the algorithm for the lower latency and the higher accuracy. And then the last, implement a cloud-based redactable blockchain technology for secure data storage and secure modification of the data also. And then define the smart contract to manage the access control and redaction policies, that means based on the user, role of the user, okay, we provide the access to the different user. Ensure the patient and healthcare provider can securely update the medical records, okay, and maintain the audit trail for all the data modification to ensure the transparency. That means it also maintain the historical data. Or suppose initially if we store the data D1 in a cloud server, and after some time if we modify the data D1, okay, and suppose the new data is D11, okay, so it is necessary to maintain both the copies in a cloud server, okay, for the purpose of the transparency. Then conduct the regular security assessment and compliance check. Thank you. So basically here in this paper the author suggested 4-tier architecture for the purpose of handling, monitoring and controlling the patient data. Okay, so basically here what happened, they use the 3-tier architecture. Okay, in a first tier what happened, Simply they collect the patient data using the WBS, that means the wireless body sensors, okay, and using the gateway. And in a second tier, exactly what happened, they use the different types of the algorithm. Basically they use the two types of the algorithm. MTBO algorithm for the purpose of optimization, because here whatever the data the sensor collect, okay, from the different patient, although the data are organized in a different cluster, then now each and every cluster produce their own result. Okay, so whatever the result produced by the cluster, we need to select the better result. Yes or no? That means we select the optimal solution, and for that optimal solution, basically it uses the MTBO algorithm. And second is the seahorse optimization algorithm. Basically, seahorse optimization algorithm is a new algorithm. I already told you. Okay, it is not a blockchain algorithm. Okay, basically it is used to predict the movement of the seahorse. Okay. Under the different climate situation. Here in a blockchain, basically the seahorse optimization algorithm is used to predict or to check the performance of the different node, or to check the performance of the different cluster. Okay, based on the data captured by the sensor, or based on the data provided by the external sources. Okay, where once we form the cluster, then basically check the performance of the cluster. Okay, for that purpose, basically it uses the seahorse optimization algorithm. In third tier, basically it uses the reinforcement learning algorithm. Okay, that means whatever the problem with the patient, for each and every problem there is a separate agent. Okay, and then each and every agent, that means each agent is responsible to handle the particular problem only. But finally they combine the result, and lastly basically they store the data in a cloud. But suppose once we store the data in a cloud, in the future if one can if one want to modify the data, then they can easily modify the data using the redactable blockchain technology. So this is the basic idea behind the papers.